In this video, I wanted to talk about how to use R in order to fit mixed effect models. Unfortunately, there is a little snag here. R uses a particular formulation of mixed effects model, which makes the R syntax somewhat counterintuitive. I shall devote this video to explain the formulation used by R. As our running example, we shall take the data that we had from the tablet experiment. So we have got the 10 tablets and we have got measurements using the HPLC method, a column of 10 numbers, and also corresponding 10 numbers measured by the NIR method. Now we have seen how to fit a model, how to formulate a random effects model. So our model was like this: Yij equal to mu plus alpha I plus bj plus epsilon ij. Let us understand the notation clearly. Here we have written this entire thing as two columns, with one column devoted to tablets. But when we want to cast it in this linear model form, then we have to write them as single column of 20 numbers. All these numbers will be listed under these things, and the methods, they are encoded as j, and the methods are encoded as I and the tablets are encoded as j. So I takes two values, HPLC and NIR, so 1 and 2. J takes 10 values, those are the tablets. You already know how to present the data in that format in our R setup. So we think of the box diagram, and the input, there are two inputs, the tablet input and the method input, one output, so what we have measured. So our final data set will not look like this, it will look like three columns. Each column has 20 numbers. The first column gives you, say, the tablets. They will be 1 to 10 followed by 1 to 10 again. And the second column is given by the methods, so that is 1 to 1 to 1 to, and the final column will give all these 20 numbers. So that's how the layout will be done. Now here I have assumed that the effect due to j is a random effect, so bj with suitable distributional assumptions that I have not given here. Now if I want to write this in form of a design matrix, then the design matrix will be like this. So let's understand carefully. Here I am assuming that j changes the fastest. So the first observation is y11, then y12, then y13, then y1. Right. So all the I equal to 1 cases will be listed first. So this column is for the mu. This is for I equal to 1. So it is alpha 1 column. Here they are just absent. This is the alpha 2 columns. So the first 10 you do not have it. You have it only the last things. And these are the j columns. And there are exactly 10 j columns. So tablet 1, tablet 1. So both this line and this line correspond to tablet 1. The second and the 12th line, they correspond to tablet 2, and so on. Now I have drawn a vertical separator. This is for the fixed effects, and this is for the random effects. So what I call the X matrix and the Z matrix. So naturally you will think that this is a design matrix and that is another design matrix. So when we want to specify the mixed effects model in R, we have to specify two design matrices. We already know how to represent a design matrix using a formula object, that is tilde notation. So we'll just have to do it twice. So the same syntax here as well as here. Now that is the way in which most standard softwares think, like SAS, SPSS or SysTac. But unfortunately, R has its own idiosyncrasy, which makes the syntax quite counterintuitive. R introduces the concept of grouping.